Hello and welcome to another lab video or video lab activity. The purpose of this video lab activity is to help you visualize this huge number called Avogadro's number, 6.02 times 10 to the 23rd, which would bury us in 6,500 miles if there was a mole or Avogadro's number of marshmallows. But we're talking about atoms, molecules, formula units that are so tiny we can't even imagine. This number that is so big we can't even imagine starts to make sense and to provide that visual. You need to have this lab handout ready to go. So if you don't have that lab handout ready yet, pause this video, get this downloaded from Schoology so that you can fill this out as I show you the lab samples. So you'll notice that the chemical the chemical name has been given to you. The chemical formula, you will, if it's an element, you will just copy that off the periodic table. If it is a ionic compound, which means you're dealing with ions, positive and negative pieces, you need to put those pieces together to make the formula. If it is a non-metal, then you would have to be you would have to get it from the name, or you might have to look a couple of these up, and I'll give you a hint about that. All right. For description, you will be using what you can see in the lab. So we'll kind of do that together. For mass of sample, this is the molar mass. So you're using grams per mole. So you need to get that from the periodic table. So once you have the correct formula, you'll know what elements you're dealing with. You'll add up those molar masses if it's a compound to get the mass of the sample in grams per mole. And if it's an element, then you don't have to add anything up. Then you just put that number there. Notice that all of these lab samples are 1 mole, meaning that they are all 6.02 times 10 to the 23rd either atoms, formula units, or molecules. So you have to put the label on this number depending on what sample you're looking at. So a quick review, if it's an element, the label on Avogadro's number is atoms. If it is a ionic compound, meaning you have a metal piece and a non-metal piece, or a positive piece and a negative piece, the label on Avogadro's number is Fu for formula units. And if you are dealing with all non-metals, no positives and negatives, then that is a covalently bonded compound. So the label is molecules. So that was from our notes for today. So if that's not sounding familiar, you should watch those video notes before you do this video lab. Okay, let's get into it. So the first sample that I want to show you this sample of tin. So this sample of tin, you can see that the container that I'm using is about 250 milliliters. And you can see that this sample takes up about 100 milliliters. You can see that the particles are kind of like crumbly looking silver pieces. You can kind of hear it. They sound kind of hard. So it kind of gives you an idea of what we're looking at in terms of this sample. So fill in the chemical formula for tin you'll get from the periodic table. The description is what you're filling in right now. That it takes up about 100 milliliters of space. It's kind of silvery, hard pieces. That's kind of what you're looking at. All right. The next one that we're going to do is, so for mass of sample, you would have to get that from the periodic table just for tin. And then the number of moles is 1. And then you have to decide, would this be atom, molecules, or formula unit? Remember, it's just an element. Okay, next one. The next one is benzoic acid. And you can see that this container is a lot bigger. This container is 1,000 milliliters big. And you can see that this takes up, it's kind of an estimation, but somewhere around 375, 400 milliliters. So that's how big the sample is. You can see the particles are kind of like fluffy and kind of white. They're a little bit sparkly, but that's the description. The formula for benzoic acid, guess what? I'm going to make you work for it. You have to look that up. So look up the formula for benzoic acid. You can use the internet. For mass of the sample, you'll need to add up the different elements that are in the formula. And then this is a 1 mole sample, so giving you a visual of what 1 mole of benzoic acid looks like. And then when you have the formula, you'll decide, is this the Avogadro's number label, is it an atom, molecule, or formula unit? All right, next one. The next one I want to show you is called ammonium dichromate. You can see that it's kind of like orangey crystals. The formula you'll be able to find because ammonium is an ion on your ion guide sheet. Dichromate is an ion on your ion guide sheet. Look up their two formulas, balance the charges, put them together. That will be the chemical formula. So description, this is again a 250 milliliter bottle or Erlenmeyer flask. And you can see that it fills it up pretty full. So about 200 milliliters or so. And again, it kind of looks like orange sugar. So they're kind of crystals, definitely orange colored. It's kind of heavy. So that's ammonium dichromate. For the molar mass, you'll need to add up the different elements that are in the chemical formula. This is a 1 mole sample, and then you have to decide after you see the chemical formula, will this be in atoms, formula units, or molecules? Okay, our next sample we're going to use is water, and I know you know what water looks like, but I want to show you what 1 mole of water looks like. So you can see that the chemical formula is H2O. The description is that it's a clear liquid. This is a 50 milliliter beaker. That's how big this is, so to kind of see it in reference to like other containers. And it's about 18 milliliters. So in terms of the space that it takes up, so if you compare it to some of these other containers, it's really little. Clear liquid, because that's we know that's what water looks like. But when you get to compare it to some of these other samples, you'll kind of see what that means. So 1 mole of water, it's about 18 milliliters is how much space it takes up, kind of a clear liquid. So different than all of the other ones, but kind of just to give you it. So for your mass of your sample, you'll need to add up 2 hydrogens from the periodic table plus 1 oxygen. And then because it's H2O, then you'll have to make a decision. So is that an atom, a molecule, or a formula unit? All right, next one we're going to look at is lead. So lead, the chemical formula, it's just lead, so you're going to get that from the periodic table. The description, so again, I used a 250 milliliter flask, and you can see that this barely even comes up to the 50 mark. So pretty small for 1 mole sample. The mass you will get from the periodic table, but you can see that they're like little circles, little beads kind of. It is pretty heavy just because the lead sample is lots of particles packed in a little space. And you can see that they're little like kind of blackish gray little beads. And again, the sample size is small. It's less than 50 milliliters, and that's your lead. So then you have to decide, okay, so is this an atom, a molecule, or a formula unit? So that's part of what we're reviewing today. The next one I want to show you is sucrose. So sucrose, this is another one that you're going to have to do a little bit of research. Look up sucrose on the internet. You'll find the chemical formula. For description, again, this is a 250 milliliter Erlenmeyer flask, and this takes up about 150 milliliters. Sucrose, the common name is sugar. So it does look like sugar because it is. So kind of white crystals. And in terms of heaviness, it's not super heavy. It's kind of about middle. And then to get the mass, you'll need to add up the elements that make sucrose. It is a 1 mole sample. And so then you'll be able to decide when you see the formula, is this an atom, a molecule, or a formula unit? The next one I want to show you is called potassium permanganate. So I'm going to give you a hint. Potassium is a metal on the periodic table, and permanganate is on your ion guide sheet. So you're going to put those pieces together to get your chemical formula. For description, again, this is a 250 milliliter Erlenmeyer flask, and this takes up about 150 milliliters. The sample is kind of purplish gray. They're a little bit sparkly. They're kind of crystals, kind of like little, they look kind of like sand chunks kind of too. They're not perfect shape crystals. They're more like irregular chunks, but it is kind of a purplish gray color if you can see that. Potassium permanganate. To get the mass of the sample, you'll need to add up the molar masses from the periodic table from the chemical formula. And then you have to decide, because this is a metal and this is a negative ion, is this mean this is a formula unit, atom, or molecule? One more sample I want to show you so that you start to get a comparison of these different moles is nickel chloride. So something totally different looking. So nickel 2 chloride. Nickel is the metal. The Roman numeral tells you what the charge is. So I'm giving you a big hint. The fact that these are dealing with charges. And then chloride, remember, is just the element, chlorine. Put those pieces together to get the chemical formula. The description, look at this. It's kind of like a greenish powder. I am using this one happens to be a 500 milliliter flask, and you can see it's kind of stuck to the side, but you can see that it probably would be around 250 milliliters if all of this, I can't get it to move down, but it would probably be around 250 milliliters, just to kind of give an idea of the space of it. So kind of greenish powdery crystals, takes up about maybe 200, 250 milliliters of the container. The mass of the sample, you would add up the elements in the chemical formula. And then because nickel is a metal and chloride is a nonmetal, that will help you to decide, is this an atom? Is this a molecule? Or is this a formula unit? All right. So then I'm going to kind of just give you a chance to look at all of these kind of set up on their own. So I can show you, let me kind of, there we go. So kind of showing you the different sizes of the containers. There we go. Showing you the different sizes of the containers kind of next to each other. We got the sun shining on them a little bit, but you can kind of see that, oh yeah, so now these are all a 1 mole sample of different chemicals. You can pause the video at any time if you want to kind of be able to see them in comparison. Here now you can see all 8 of them next to each other. So seeing that some containers are really small, some containers are much bigger. Some samples are much smaller, some samples are much bigger. But what I want you to realize is that all of these samples are 1 mole. So now again, you've got a visual of what this word mole looks like. And all of these samples are 6.02 times 10 to the 23rd particle pieces. It's just that some of those particles are called atoms, some of the particles are called formula units, and some of the particles are called molecules. So one more time, I'll kind of go in a little bit. So we've got tin, benzoic acid, ammonium dichromate, water is that little one, lead, sucrose, potassium dichromate, and then nickel chloride. All right, so now you know a little bit more about Avogadro's number and what that actually looks like in a lab sample. So then that was the main purpose of this. There are just 2 conclusion questions I want you to think about at the back of this handout, or the second page of this handout, so that you can kind of just do some conclusion processing. All right, thanks for being my lab partner for this activity. And now you know some more about Avogadro.